All right, guys, so we're going to go on and get started going over the review sheet. Now, again, I think you all already know we do have inclement weather coming, yes. I am hoping that it holds off till tomorrow, after tomorrow, because then y'all can actually take this test and be good to go. If we are not here tomorrow, this test is going to be whatever the next day we get back. And it's not, we are running, because we are getting closer to the end of the semester, and it's not so much that, it's more the time we have between now and spring break is running short. And we're getting closer and closer to the point where it's enough time to start covering a chapter, but not quite enough time to finish a chapter, so having that extended any further is kind of getting in a rough spot. So that, and this is the second time we've gone through this, so I feel like y'all should be comfortable with the material here. I do have a set selection of problems I've already picked out that we are going to go over. If there are any that we don't get to, because we will get to at least one of each type that will show up. But I do have videos of all of them, every single problem on this review sheet being covered. And they've already been attached to Google Classroom. There are 3 different videos covering it. So, getting into this first part here, talking about 1 through 6, determining whether it's direct, inverse, or neither. Well, the general formulas for our direct variation come in the form of either y is equal to a times x, or really we could also say that x is equal to a times y. The direct variation is just saying as one increases, the other is going to increase as well. Now we can also write this so that a is by itself. So that I could say that a is equal to y divided by x, or a is equal to x divided by y. And really for this here, we're just talking about 2 variables and how they relate to each other. The other type we had was inverse, which is telling us that y is equal to a divided by x. And we could easily have just flipped those and say that x is equal to a divided by y. And also, just like with direct variation, we can get both of the variables on the same side by using our properties of multiplication and division, which gives us this here. Now, unlike direct variation, we don't have 2 examples for this here, a equals x times y. Because, I mean, I could change it and say a is equal to y times x. But that's the exact same thing. It really doesn't give us a different form or something else to look at. And really, we can use these here to determine whether each one of these is direct or inverse variation. Well, if we look at number 1, 8y equals x would be direct. And it's just really matching up to one of the equations that we have as by definition for direct variation. How about number 2? Inverse. Number 6, neither. And what's the giveaway for this one here? The plus. How about number 4? Inverse. Number 5, inverse. And lastly, number 6. And really with all these here, we're just comparing them to these general equations and which one do they match up to. Because again, a in all of these cases for direct and inverse by definition is just a number. It could be a whole number, it could be a fraction, it could be positive, negative, it could be a decimal. It's just a number. And seeing which one does it match up to. Any other questions on the first 6? 7 through 9 is not on the test. All right. So that brings us to simplifying. And whenever we simplify, we want to eliminate any like terms on top and bottom. We can look at number 10 first. So we want to factor in any way, shape, form that we can. So looking at the numerator for this here, which is 2x squared, well, how many terms do we have? One, it's just 2x squared. Okay, well, there's nothing we can do with it. Because for us to be able to factor in any way, shape, or form, we need at least 2 terms. We need at least 2 terms. Now, the denominator does have 2 terms. So whenever we look at that, the first thing we need to look for is a greatest common factor. Is there a greatest common factor between 3x squared and 4x? They both have an x. They both have a variable. So we can factor it out. And if I factor an x out of 3x squared, we're left with 3x minus. And x factored out of 4x leaves us with 4. Now, do we have something in common on top and bottom? Yes, because we have an x and an x squared. And that would cancel 1x on top and bottom. So the x squared is going to become just an x. And the one on bottom is gone, because there's only one on bottom. So that leaves us with what in the denominator? Our 3x minus 4. And again, the 3x minus 4 is a single term because of the subtraction. Because addition, subtraction really lock these together. The only way we can really do the simplification with the x over x squared is because x and the 3x minus 4 are being multiplied, not added or subtracted, so we can actually simplify. Well, that's it. That is it. That's all I have to do for this here. Any other questions on number 10? All right, I'm not going to look at 11 or 12 here, mainly because we're not going to deal, I'm not going to make y'all do cubics or factoring by grouping on the test. But it would be helpful to look at 13. Now 13, we're going to have to factor the numerator and the denominator. Now looking at these two here, because we're going to have to factor both, and most likely we are going to need 2 sets of parentheses. Now, I keep doing this, but I didn't intentionally skip over greatest common factor. But looking at the numerator, x squared minus 4x minus 12, is there a greatest common factor? Is there a number that will go into all 3? Is there a term that can be factored out of all 3? No. How about x squared minus 4? No. So most of the time, I don't even look at it, because when I look at the problem, okay, there's no like terms, we're just going to move on. But it is good to keep an eye out for them, because they'll make it a little bit easier to solve if we find them. Now looking at the numerator and denominator, which one do y'all like to factor better? The denominator, x squared minus 4, yes? Which would be? Almost x plus 2 and x minus 2. Because it's a difference of perfect squares, so we're looking what multiplies together to give us x squared, which is our x and x. And the number that multiplies together to give us 4 is 2 and 2. Now it's good to find the one we can factor easier, especially the difference of perfect squares, because if anything's going to simplify, we need the same thing on top and bottom. Sorry. You're good. So the reason we want that, because if anything simplifies on top and bottom, well, we need one of them on top to be either x plus 2 or x minus 2. So it gives us an idea of what we need to do. Now the negative 12 tells me the signs are going to be opposite. One's positive and one is negative. Now the factors of x squared are x and x. Now the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Well, if we're going to get something to factor, I need to use 2 and. Well, the 4x in the middle is negative. So for these to work, we would need the 6 to be negative. And again, we can check it to make sure. And if we multiply through, x times our negative 6 would be negative 6x. The 2 times x would be our plus 2x, which would give us a negative 4x, which is the middle term that we wanted. Any questions on this here? Well, at this point here, we can simplify what's in common on top and bottom, which would be the x plus 2 and x plus 2, leaving us with x minus 6 over x minus 2. And that's it. Because again, we need to remember that the x minus 2 and x minus 6 are a single term, so we can't just simplify the x and x. So this here would be our final answer. Any other questions on this one here? All right. I'm going to look at 15 next, because we don't, last time I checked, the test didn't have any single term multiplication. We only had one term on top and bottom. We didn't have any addition or subtraction. Most of them are going to look like 15, where we have multiple terms on top and bottom of each expression. We can have some single terms like 2x, but not all of them are going to be that one term in the numerator and denominator of each. Now, to start this off, it would be good to factor each one that we can. Well, x minus 1 and 2x are as simplified as they get. They don't have a greatest common factor, and there's no way to rewrite them as sets of parentheses in factored form. Now, looking at the numerator, x squared minus 4x, it's tempting to do difference of perfect squares, but we have the negative 4x. Exactly, we do have a greatest common factor of x. X is in common in both terms. So we can pull an x out, which would leave us with x minus 4 inside the parentheses. And well, since the degree inside the parentheses is 1, that's as simplified as it gets, because we don't have an x squared anymore. Well, that just leaves us with our x squared plus 3x minus 4. So when we factor this one here, since the 4 is negative, it tells us our signs are opposite. One is going to be positive, one is going to be negative. Now the factors of x squared are x and x. Well, if I'm going to get something to simplify, I need one of these sets of parentheses to be what? That's the only set of parentheses we have in the denominator, x minus 1. So we would need one of these to be x minus 1, which does work, and it would give us a 4, because the factors of 4 that work for this are 4 and 1. And if we check it, we would get x times negative 1 is negative x, plus 4x, which should give us a positive 3x, which is the middle term. So that does work. Any questions on this here before we multiply? Well, when we deal with multiplication, really the terms on top get all stuck together, the terms on bottom all go together, which is really telling us that the x minus 1 and x minus 1 will. Is there anything else? We have an x outside the parentheses and an x outside the parentheses. Well, those would cancel out, because in both cases we have how many on top and bottom? 1 and 1, yes? So they are gone, telling us that in the numerator we have x minus 4 and in the denominator we have 2. You'll need to change the answer key. It was pointed out to me first hour. I dropped it for some reason writing the answer key. So that is the correct answer. The answer key, you just need to add a 2 in the denominator, because I, for some reason, writing the answer key left it out. And most likely that was pointed out to me last year and probably the year before, and I just for some reason forgot to change it. So this here is what the answer should be. Any other questions on 15? All right. Let's look at 16. So we look at 16 here. We do need to factor each one of these here. And again, as we saw in the last one, if we do have a way to kind of give us a hint, it is helpful. So looking at these 4 polynomials, I'm going to factor the 2x squared plus 4x first, because they both have a greatest common factor of 2x. So if I factor that out, 2x out of 2x squared leaves me with a single x plus 2. So we get x plus 2, which is kind of telling me that either the x squared plus 4x plus 4 has an x plus 2, or the x squared minus 4x plus 3 has an x plus 2. Well, I know the 4x squared minus 4x plus 3 is not going to have an x plus 2. Is this 2 a factor of 3? No. So why not? Let's go over here. X squared plus 4x plus 4. Because most likely it'll have an x plus 2. So if we look at this here, well, since the 4 is positive, our signs are the same and match the sign of the middle term. So we have plus and plus. Factors of x squared are x and x. And well, the factors of 4 that we would want are 2 and 2. And that would actually, if we checked, it would give us a middle term of 4x. So that's kind of nice. Well, which one do you all want to factor next? Our one last numerator or the last denominator? We can do the other denominator. Now, since the 3 is positive, our signs are the same and match the sign of the middle term, which is negative and negative. The factors of x squared are x and x, and well, the only factors of 3 are 1 and 3. If we did check this, we would get a middle term of negative 4x. Which brings us to the last one. Now, since the 4 is negative, our signs are opposite. Now, that will tell us that we have plus and minus. Now, the factors of x squared are x and x. Now, we need the factors of 4, 1 and 4, or 2 and 2. Well, 1 and 4, we would want the 4 to be positive or negative. Positive, because if the 1 is negative, well, now we have an x minus 1 on top and bottom. And that would give us positive 3x if we checked it. Well, now we do everything multiplied together, so we can go on and multiply the numerators, multiply the denominators, and see what cancels. We do have an x plus 2 and an x plus 2, which will cancel. We have an x minus 1 and an x minus 1 that will cancel. Let's see what that leaves us with. In the numerator, we do still have this 2x. I move it out front. Any term that's not inside the parentheses, it's just a greatest common factor, let's keep it in the front. The other thing that's left in the numerator is the x plus 4. Over. And that's it. There's no point in multiplying these through or multiplying them back out because it doesn't give us an any simpler answer than we already got. Any other questions on 16? All right. Let's look at number 19. If you feel very comfortable with these here, you can go on and do the 2 steps all at once. But the biggest thing you need to make sure to do with this division is to change it from division to multiplication and flip the second one. Which for the second one would give us x squared plus 12x plus 20 over x squared plus 13x plus 40. It's very interesting of how this actually works and the properties behind it, but unfortunately we don't have a whole lot of time to actually delve into that. Now, the numerator and denominator of our first expression stay the same. if you do feel comfortable doing that switch, changing it from division to multiplication and flipping and factoring all of these here, you can do that. But if you don't feel comfortable doing that, rewrite it in multiplication form and then factor. So now we can factor all of these here. Now, unfortunately, we don't have a nice difference of perfect squares here, so we really just need to pick one to start with and go from there. If y'all don't have any preference, I'm just going to start on the top left. Well, since the 40 is negative, our signs are opposite. And the factors of x squared are x and x. So we're looking at the factors of 40, which are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. So if we went through and worked it out, we would end up getting 5 and 8. And the 8 would be negative. And if we check that, we would get a negative 3x doing our multiplication of x times negative 8. 5 times 8 would give us our negative 3x. Okay. So we can drop down to the x squared plus 8x minus 20. Well, since the 20 is still negative, our signs are opposite. Our factors of x are x and x. So now we need to look at the factors of 20, which is 1 and 20, 2 and 10, 4 and 5. And it would be very tempting to use the 5. But unfortunately, it's 10 and 2. Because our 4 and 5, if we did use it and checked it, we would either get positive x or negative x as the middle term. So unfortunately, it doesn't work for this one here. So for the first set, our first rational expression, we don't have anything in common on top and bottom. But what that means is I'm expecting something in the second one to be in common on top and bottom. So we can just start with x squared plus 12x plus 20. Since 20 is positive, the signs are the same and match the sign of the middle term, which gives us plus and plus. Well, factors of x squared are x and x, 10 and 2. Because that's the only way that we will have something in common on top and bottom. And well, 10 plus 2 is 12. And we can just add or subtract the constant terms because there's not a number in front of x. It's a nice little shortcut we can use. The denominator, since 40 is positive, the signs are the same and match the sign of the middle term, which gives us another plus and plus. Our factors of x squared are x and x. And we're going to use 5 and 8. Because our 5 plus 8 would give us 30 or 13. Any questions on how we got to this point here? Now, luckily with multiplication, they're just going to all bump together when we multiply them. So I like just creating one here, and we can cancel out what's in common on top and bottom. Well, our x plus 10 and x plus 10 would cancel. X plus 5 and x plus 5 would cancel. Got to get above that watermark. Which would leave us with x minus 8 times x plus 2 over x plus 8 times x minus 2. If you have them in a flipped order, had in the numerator x plus 2 first instead of x minus 8 first, that's fine. If you have the x minus 2 first on bottom instead of x plus 8, that's fine. And this here is as simplified as it gets. The only way we could have canceled something out on top and bottom is if the signs for both of them were opposite. So here, for x minus 8, x plus 8, well, the x's have an opposite sign, but the x's are the same. So I would either need that the numerator had negative x minus 8, or that the denominator had negative x plus 8. Then we could have factored out a negative. But here, if the constant term's the only thing that has a different sign, we can't cancel it out. Any other questions on 19, I think, is what we're at? Yes? We good with this here? All right, let's look at 21. Addition, subtraction. Now, addition, subtraction, unlike multiplication, division, we need the denominators to be the same, because the only way we can add fractions is if the denominators are the exact same. Well, here we have 3x plus 2, 3x plus 2, and 3x plus 2 as the denominators. Okay. Luckily, we can go on and add and subtract. Here, we're just adding across all three, so it's not that bad of a step to do. Well, looking across all three, 9x squared is the only term that has an x squared, so we can't combine it with anything else. But I do have a 6x and a, which we can add together to give us plus. And lastly, we have negative 1 plus 5 plus 4. If you'd wanted to write this all on one term, so the 9x squared plus 6x minus 1 plus 6x plus 5 all in the numerator and then combine like terms, that's fine too. And I would do that especially if one of these was a subtraction. Because if we're subtracting, we do need to make sure we distribute that negative across whatever the second one is, because it would make a difference. But this one here, it would do that. Since both of them are plus, addition really doesn't change, or doesn't change the signs of the numerator. We're just adding. Subtraction, we do need to be careful. Well, we need to factor the numerator if it's possible, just in case there is something in common on top and bottom. Because, I mean, we might have something to cancel out if our x squared term had a factor of 3x, or if the constant term had a factor of 2. Well, wait a minute. 9x squared does have a common, or has a factor of 3x, yes? 4 does have a factor of 2. So most likely, this here will factor and simplify. All right. So if we factor this here, well, since 4 is positive, our signs are the same and they match the sign of the middle term. So plus and plus. Well, now we need the factors of 9x squared and 4. Most likely, if we want something to simplify, we need our 3x and 3x. Factors of 4 are 2 and 2. Now, if we did check this here, we would end up getting 6x plus 6x, which gives us 12x, which is the middle term that we wanted. So it does work out. And interestingly enough, we do have something in common on top and. So 3x plus 2 and 3x plus 2 will cancel, leaving us with 3x plus 2. Any questions on this here? Are we ready for the next one? We're not going to go too far. We're going to look at 22. Now, with any addition or subtraction problems, because the last one was kind of nice because the denominators are all the same, if there's a denominator that is factorable, we need to factor it. So the x squared plus 5x minus 14 needs to be factored. Well, the x plus 7 is as factored as it can possibly get. There's no greatest common factor. There's nothing we can do with it. So we're going to leave it as x minus 7. Now, the x squared minus 5 in the numerator, for one thing, is not factorable. But even if it was an x squared minus 4, a difference of perfect squares, we're going to leave it alone. Because again, when we add or subtract, we're adding and subtracting the numerator. So if there's any like common if there are any like terms, not common factors, any like terms in the numerator, we're going to have to add or subtract them. So if we did factor it, well, we'd have to unfactor it. We'd have to actually use our distributive property for us to be able to add and subtract the numerators. Any questions on that so far? Well, we need to factor the x squared plus 5x minus 14. It'd be kind of nice if one of the factors was x plus 7. Then we'd already have something in common in both terms. Well, since the 14 is negative, our signs are opposite. Factors of x squared are x and x. And well, interestingly enough, one of the factors of 14 are 2 and 7. And 7 minus 2 is positive 5. Well, the middle term is a positive 5x. Okay. Well, both denominators do have an x plus 7, yes? But the one on the left also has a what? An x minus 2. So the one on the right needs n minus 2. And we can multiply that on top and bottom. And when we do that, the denominators for both will be x plus 7 times x minus 2. And again, since this is subtraction, we do need to be careful with our signs, especially with the second set of parentheses. Now at this point here, I'm going to go on and distribute these here. X times x would give us x squared minus 2x plus 3x minus 6 if we distribute that out. Now if you wanted to have written it all in one fraction, that's perfectly fine, but do be careful with that negative in the middle. Any questions on how we got to this here? Well, I think I got my elbow too close to the screen. Nope, not even that. Okay. Here. So the first one, we do have our x squared minus 5. Since there's not a negative in front of the first fraction, we don't have to worry too much about the parentheses. I'm re-putting the parentheses up there just so we can make sure the signs for the second term, we get them right. Now we would have x squared. The negative 2x plus 3x would be plus x minus 6. Now, when we drop the parentheses, we do need to make sure we distribute that negative through. Now, if you'd have felt comfortable skipping some of these steps to get here, that's fine. But we do need to be careful of those negatives. Because since we're subtracting the x squared plus x minus 6, the x squared becomes negative, the x becomes negative, and the 6 becomes positive. Now looking at this here for combining like terms, well, x squared minus x, that is 0. It cancels out. Now we don't have any like terms with the negative x, so it's just negative x. Negative 5 plus 6 is going to be plus 1. Now any questions before we move on from here? Okay. Now in the numerator, we can factor that negative out. I can make the x positive and I can make the 1 negative. Do we have an x plus 1, or here it would end up being x minus 1 in the denominator? Well, no. So even if I did factor it out, it actually wouldn't change anything. That would be the final answer. So if I did have a x minus 1 in the denominator, then we would have needed to factor the negative out for them to be the same. But since x minus 1 isn't a factor in the denominator, we can actually leave it as that there. We're done. Any questions on this here? And that was number 22. We good with 21 and 22? All right. We're going to look at 26 and 29, finding the least common multiple. So we'll look at 26 first. Now, with any of this here, before we find what the least common multiple is, we need to make sure all the terms are as factored or as simplified as we possibly can. And for this here, 2x squared, that's as simplified as it gets. It's only one term. Now, the 4x plus 12 does have a greatest common factor of 4 that we can factor out. We can factor the 4 out of 4x and 12. And if I factor a 4 out of 4x, I'm left with x. And if I factor a 4 out of 12, I'm left with 3. So the 4 factored out of 4x plus 3 is x, or not 4x plus 3, 4x plus 12 would give us 4 times x plus 3. And those would be as simplified as it gets. Well, one thing I know I'll need in both of these here is n x plus 3, because one of them does have it, yes? What other variables do we have? Have an x squared. Because really, any of the parentheses that we have, we'll need them, at least one from each one. We'll need them to get them to be the same. Now, the kind of trickier one, which I think is trickier, is the 4 and 2, because with some numbers, it's kind of a little harder to see. Luckily, with this here, 2 and 4 is not too bad. What's the first number I can make both 2 and 4 be the same? 4. Because it's easier to make 2 into 4 than it is 4 into 2. Because for least common multiple, we're going up. We could have it match one of the numbers, but we can't make them smaller. We can only make them bigger. So we can match the biggest number of the group, but it can't match the smallest. So here, it's 4, and actually 4x squared times x plus 3 is the final answer. Any other questions on this here? Okay. Now we'll look at 29. And again, so for 29, we do need to look for greatest common factors. Greatest common factors. Well, 4x squared minus 16 does have a greatest common factor of 4, which would leave us with an x squared minus 4. Now, 4x squared minus 16 is a difference of perfect squares, but we do need to pull the 4 out first. Well, 4x squared, or x squared minus 4 is still a difference of perfect squares, which would be our x minus 2 and x plus 2. And that would be simplified because each one of the x minus 2 and x plus 2, the degree is 1. We don't have an x squared anymore. So that is factored into simplest form. Now our 6x squared minus 24x plus 24 does have a greatest common factor of 6. When we factor it out, it would give us an x squared minus 4x plus 4. Because we're just pulling 6 or dividing each term by 6. Now to factor the x squared minus 4x plus 4, well, since the 4 is positive, our signs are the same and match the sign of the middle term, which would be negative and negative. The factors of x squared are x and x. And the factors of 4 are 2 and 2, what we would need. Questions on how we factored either one of these here? Least common multiple. Well, I know I'm going to need an x plus 2, because it did show up at least once, yes? Well, we would also need n, because it showed up at least once, yes? Do I need any other set of parentheses? Exactly, I'm going to need one more x minus 2. Because for the one in blue, x minus 2 showed up how many times? Twice. The x plus 2 only showed up once. Since it only showed up once here, we only need it once. Even though the x minus 2 showed up once here, it showed up how many times over here? Twice, so we need it twice. Those aren't that bad. Now we just need to find the first number that I can turn both 4 and 6 into, which is not 6, but it actually works out to be 12. And that's it there. Any other questions on 26 or 29? We're good with both of these here? Yes? Okay. We're going to do one more. 38 is going to be the last one that we're going to do, and that should be a minus. I know the bell's going to ring before we finish this problem here. Stay with me until then. Stay with me until we finish this one out. All right, that way you have it just in case we aren't here tomorrow. Now, with any of the solving, it is good to find the restrictions and making sure all the denominators are factored first. Because once we get that, if there are any restrictions, we know that the solutions that come out to be those restrictions don't work. And the ones that do have restrictions, it's going to say in the directions, hey, make sure to look for restrictions. So those might show up there. Now, the denominator for the first one is factorable, our x squared plus x minus 6. Now, since we're short on time, I'm going to go on and just tell you that this ends up being x plus 3 times x minus 2. Well, that does kind of let us know that x cannot be 2 or negative 3. It can't be 2 for our x minus 2 and x minus 2 and make both of those 0. And negative 3 would make x plus 3 be 0. Now I'm starting off with our x plus 3 and x minus 2 because I know for the first term our negative 5, that would cancel out both of the denominators. Because x plus 3 times x minus 2, x plus 3 and x plus 3 would cancel. X minus 2 and x minus 2 would cancel for that there. Let's see if anything else cancels. Well, the middle term of 2 is just going to stay 2 because there's no denominator. And the last one, the negative 2, x minus 2 and x minus 2 would cancel, yes? Is there anything left in the denominator? No. Okay, so I have it. And sometimes, or not sometimes, a lot of times it's easier to add factors into all three than it is to try to pull them back if we go too high. Now what that leaves us with is negative 5 is equal to 2 times, well, x squared plus x minus 6. Because I can change that x plus 3 times x minus 2 back into that. Because where did we get it from? We got it as the factors of x squared plus x minus 6. So it's not too bad to go back to it if we came from it. Now our next main step is going to be to distribute. Here are the 2, which would give us 2x squared plus 2x minus 12. Well, the x plus 3 times x minus 3 is our x minus 9. Realistically, x plus 3 times x minus 3 are the factors for a difference of perfect squares. So we can kind of go the other way around. If you wanted to, you could multiply those two, these two here together, and you would get there. It would just take a step to get there. Now, at this point here, we can combine like terms. So our 2x squared plus x squared would be 3x squared. Plus 2x minus 21. Luckily, we're not too far from the end. Since this is a quadratic, we would need to add 5 to both sides, because we do need to get this thing equal to 0, which would tell us 0 is equal to 3x squared plus 2x minus 16. Now we could factor this. we could factor this. Don't do this now. Stop it. It would happen right now. Where in the heck did it go? There we go. Now, if we did factor it, factoring is going to be the best option. And I say that because since the 3x squared, we have a 3 in front of the x squared, most likely our answer is going to be fraction. Because we're going to have that as part of the factors. Now, since the 16 is negative, factoring it, one's going to be positive, one's going to be negative. Factors of 3x squared are going to be 3x and x, and it works out that the factors of 16 that we want are 8 and 2, and it does work out these are the correct factors. Now, because we have two things multiplied together to equal 0, one of them is going to be 0. Either the 3x plus 8 is 0, or the x minus 2 is equal to 0. Now, for the x minus 2, we would add 2 to both sides, telling us x is equal to 2. For the 3x plus 8, we would subtract 8 from both sides, telling us 3x is equal to negative 8. Divide both sides by 3. Don't need that. It would tell us that x is equal to negative 8 thirds. Well, x cannot be 2 because 2 was one of the restrictions that we listed at the top. So the only answer is x is equal to negative 8 thirds. And that's it. So again, if you do have any other questions on the other ones, there are 3 videos in Google Classroom that you can look over that will cover all of them. Y'all can go on to your next class.